Now, the next step we're going to talk about is, well, we've already seen that this is what an argument is. It's a conclusion supported by one or more premises. What do we mean by support? Well, the first thing we're going to do is we're going to learn how to illustrate the logical structure of an argument. Because arguments have logical structure, that's what makes them arguments, the way in which the propositions relate to each other. But they can have different logical structures depending on which proposition is supposed to support which. And you can reveal this logical structure using the diagramming method that we're now going to learn. Okay. Let's go on to the next set of exercises on page 96. 96. If you go to 100, you've gone 4 pages too far. All right. Now, here we have an example of an argument. Could you read it, Josh?
To be a lawyer, you need to be good at keeping track of details, and Lonnie is terrible at that, so he shouldn't go into law.
Now, how many propositions are there?
2.
Look at the numbers. 3, yes, they kind of tell you that there are 3. Now notice that there's only one sentence, so this is an example of how a single sentence can contain more than one proposition. This one's got 3. And furthermore, it asserts 3 propositions. When we list the propositions in an argument, we're only listing the ones that are asserted. Remember that distinction? When does a sentence assert a proposition?
When that proposition is meant to be taken as true.
Yes. So, for example, you can find a proposition within a sentence, which means that it's expressed. If you can find it, it's expressed. But not all expressed propositions are asserted. If there's only one proposition, then it will be asserted. In short sentences, it's always the case that the entire sentence is asserted. But sometimes you'll have longer sentences that express more than one proposition, and sometimes they can not be asserted. What's an example of when you have expressed but not asserted?
If I travel to New York, I'll meet my friends.
That would be an if-then, yes. So if you say, if I travel to New York, then I'll meet my friends. That contains I travel to New York, because that could be true or false. And I meet my friends, that can be true or false. So they're both propositions, so there are 2 propositions there, and they're obviously expressed, because if they're there, they're expressed. But are they asserted? In other words, if it's true that if I travel to New York, then I will meet my friends, is it true that I'm traveling to New York right now? No. So that would be an example of expressed, because it's there, but not asserted. The whole thing is actually itself a proposition. So propositions are a bit like numbers. How many numbers are here? 2. But actually, this constitutes another number. What's the other number?
6.
Good. You're on top of it. Yes. So the whole thing is a number. 6. Same with propositions. So you say, if P, then Q, you have 2 propositions there, but this whole thing is also a proposition. How do we know? Because it could be true or false. Is it true that if I travel to New York, then I'll meet my friends? Well, not if you don't have any friends in New York, right? So the whole thing can be true, and in fact, the whole thing is always asserted. In the whole sentence, the proposition representing the whole sentence is always asserted. But the component parts are sometimes only expressed. And that happens when you use if-then, and what else? Or. The conjunction or, that's another. But if you use the conjunction and, they're also asserted. Remember that? You better, because you got it on your homework. All right. If you came across, so, for diagramming purposes, suppose you had, I don't know, each letter represents a proposition. How many propositions, if you were listing the propositions that are asserted in this argument, how many would you list?
3.
No. 2. Because I said you have to list the propositions that are asserted. Is this asserted? Is this asserted?
No.
This is asserted because it's the only one, and this whole thing is also asserted. So if you listed the propositions, you would list this and this. However, now how many propositions are asserted?
2,
How many?
3.
3. 1, 2, 3. Okay? So if you were if I asked you to go through an argument and list all the propositions, you would list 1, 2, 3. Whereas before, if you had this, it would just be 1, 2. Okay? It'll become more clear next time when I ask you to do that. But anyway, here they've been nice and they've numbered the propositions. So we don't even have to work out how many there are. It's done for us. There are 3. All right. If you were to list them, again, I would require you to write them out in full. So I would require you, but I'm not going to do it because I'm lazy, to be a lawyer, but I will illustrate what you should. To be a lawyer, you need to be good at keeping track of details. What would the next proposition be?
Lonnie is terrible at keeping good track of details.
Yes, you can't say Lonnie is terrible at that, because the word that, what it means depends on the context. You have to write it so it's context independent. So Lonnie is terrible at keeping track of details. And then what would the last one be?
You should go shut.
Lonnie
Lonnie shouldn't go into law. Yes. You can't use the word he because that's another one of those words whose reference depends on its context. Okay, those are our 3 propositions. This is an argument. One of them will be the conclusion. Which one? Everybody.
3.
Everybody.
3.
Yes, that's right. How can you tell?
So,
It has the word so, which is an indicator word for the conclusion. But even if the word so wasn't there, how could you tell?
Because the other 2 support it.
Yeah, it's clearly the point. The point. What's the point of this thing? Well, it's to show that Lonnie shouldn't go into law. All right. Now we're going to learn how to diagram this argument. When you're diagramming an argument, the first stage is to go through and number all the propositions in the list. Here they've given you the numbers, but just to give you a hint of what horrors lie ahead, have a look at pages 120, 121. 120, 121. There you have passages full of propositions. They're passages actually taken from actually written things by actual people. And they contain arguments that you would have to go through and sort out the proposition, how many propositions there are, they're asserted. You would also have to, if they repeat the same proposition, you only count it once. And that often happens. So for example, yeah, actually that reminds me of something I figured out, something freaking obvious that I figured out the first time in 20 years. We sometimes use the word conclusion to mean what?
a summary of everything you just said.
Or the end of something. Like when my journey reaches its conclusion. Do not assume that the conclusion is always at the end of an argument. It's the point of an argument, but it's not always at the end. You can have the conclusion at the beginning. So for example, if you're on trial and the prosecution comes forward, the prosecution might say, this person here is guilty of this heinous crime, as I shall now prove. So that's the conclusion. The point is that you're guilty. But she says it right at the beginning. And then she'll probably say it several times just to hammer home the point for the conclusion, for the jury. But, you know, the conclusion is not always at the end. Of course it is here, but not always. All right, so the conclusion is Lonnie shouldn't go into law. Now, how do diagrams work? Well, there are 3 simple elements to a diagram. First of all, numbers. In this case, 1, 2, and 3. Secondly, arrows. And thirdly, and this is not in all diagrams, a plus symbol. Oh, and when there's a plus, you also use underlining. I will illustrate. So actually, there's only 3 propositions, and we already know that number 3 is the conclusion. Even with that, though, there are 4 possible diagrams of this argument, and I will give you these are 2 of them. Here's one. You don't have to draw a circle around the conclusion, but I'm going to anyway. So the first thing, so when you're diagramming an argument, first step is to list all the propositions. Then the next step is to identify which of them is the conclusion, and it won't always be the last one. In this case, it is. And then when you've done that, find the space that you've allotted for your diagram, and you write the conclusion number at the bottom. Then you have to put all the other numbers in their place as well. Well, these are the 4 possibilities. What's the difference amongst these 4? Well, there's a key difference between these 2. And the key difference between these 2 is in whether or not the premises are dependent or independent. So, premises can be either dependent or independent. According to what? According to how they support the conclusion. So I'm going to define what a dependent premise is. Oh look, it's written here already. A dependent premise is a premise that needs another premise before it can support usually the conclusion, but not always the conclusion. It might be another premise too. So it is a premise that needs another premise before it can support another proposition. Whether that other proposition be another premise or the ultimate conclusion. Now, what do I mean need another? That definition itself is again a little bit vague. Well, we'll work that out by a process of doing examples. Which, out of A and B, which do you think represents the dependent premises? B. Yes, you can see 1 and 2 are dependent on each other. Why? Well look, here 1 supports 3 by itself. Does it need any help? No. It is strong and independent. It is a rugged individual. Okay? So 1 is an independent premise. 2 is an independent premise. They don't need each other. Here, they're codependent. Right? They cling to each other. They cannot support the conclusion except working as a team. So this is how you indicate dependent premises. 1 and 2 are both dependent on each other, whereas here 1 and 2 are independent premises. Now, let's go through. Here are the 4 possibilities. Here, 1 supports 3 by itself, 2 supports 3 by itself. Here, 1 and 2 working together can support the conclusion. Here, 1 supports 2, and 2 supports the conclusion. Here it's reversed. 2 supports 1, and 1 supports the conclusion. Incidentally, in these 2, you've got an obvious premise, an obvious conclusion, and a sort of middle thing. Why is it a sort of middle thing? Well, it's not the conclusion, because the conclusion is always at the bottom. But why is it conclusion-like?
It can seem to be a conclusion from 1.
Yes, it is supported by 1. So it's, we think of conclusions as the things that are supported. Well here, this is supported by 1. But it's not the overall conclusion. In fact, it's a premise. It is a premise, but it's a type of premise that we call a sub-conclusion. It's not the overall conclusion, that's 3, but it is supported by other premises, like as conclusions are. So we call, in this case, 2 is a sub-conclusion, in this case, 1 is a sub-conclusion. All right. Who thinks, now I want you to decide, on very little information, what is the right diagram for the argument we're considering? Who says it's A? Who says it's B? Who says C or D? One of the others. Okay, so B is the overwhelming winner. Why?
You need both of them,
Why do you need both of them?
because each one, like, if you just had one or two by itself, it wouldn't be conclusive, and you should be able to.
Yeah, let's work this through. And here's the way to work this through if you're ever unsure if your diagram is correct. First of all, say the conclusion. So Lonnie shouldn't go into law. Then you ask the question, what's the evidence? And if your diagram is correct, then going to the top of an arrow that leads to the conclusion, so going to the back end of the arrow, will provide the answer. So if this was the correct diagram, then I ask, so Lonnie shouldn't go into law. What's your evidence? To be a lawyer, you need to be good at keeping track of details. Does that by itself prove that Lonnie shouldn't go into law?
No.
No, the only way it would is if you had background information about Lonnie, but you don't. You are to assume ignorance. So why doesn't that show that Lonnie shouldn't go into law?
It doesn't say anything about Lonnie at all.
It doesn't say anything about Lonnie at all. So, by itself, it's actually totally irrelevant to Lonnie. Okay? So the conclusion connects Lonnie and the law. This doesn't say anything about Lonnie. All right, let's see if this is an independent premise. Lonnie shouldn't go into law. What's your evidence? Well, Lonnie is terrible at keeping track of details. Does that prove that he shouldn't go into law?
Doesn't say
Because it
anything
makes
about
no
law.
statement.
Doesn't say anything about the law. So what this says something connecting Lonnie and the law. This doesn't mention Lonnie. This doesn't mention the law. So neither of them by themselves are even relevant to the conclusion. They don't even weakly support the conclusion. So these are not independent premises. What kind of premises are they? Dependent, which is why 2 is the correct one. Now, let's see if this works. Lonnie shouldn't go into law. What's your evidence? Well, to be a lawyer, you need to be good at keeping track of details. And incidentally, when you go up an arrow, you should be answering a what's your evidence question. When you go over a plus sign, the question that should be answered is, so what? Okay? This is going to be helpful later on when we talk about missing premises. All right, so Lonnie shouldn't go into law. What's your evidence? Well, to be a lawyer, you need to be good at keeping track of details. So what? Is this the answer? Lonnie is terrible at keeping track of details. Yes. So put them together. Lonnie can't keep track of details. To be a lawyer, you need to keep track of details. That does prove that Lonnie shouldn't go into law. Right? Now, we don't have to worry if any of this is true. Maybe it's false that all lawyers have to be good at keeping track of details. They can hire interns to do that. Or all they have to do is to be good at lying with a straight face, right? No, I shouldn't say that. I might need a lawyer. We don't have to worry about that. We're just looking at the logical structure, how the propositions are related. And this is the correct diagram for that one. All right, let's look at number 2. Ethan. And incidentally, every time this happens, it's always a guy that reads this one.
He sat next to me in class today, and the other day he smiled when I ran into him at the library. I think he's interested in me.
A little conceited, I think, Ethan. Okay, what is the conclusion?
I think he's interested in me.
Actually, let's be careful here. If the conclusion was, I think he's interested in me, what kind of evidence would be relevant? Evidence about what?
Your thoughts.
About you, about your state of mind. Because if we're trying to prove what you think, then we need to give evidence about you. But that isn't really what's going on here. What's the real conclusion of saying?
He is interested.
He is interested in me. So in fact, in this case, I think is sort of being used as an indicator word. Why is it that you think? Because of the reasons you've just given. So I think in this case is being used a bit like, it seems that, or on the basis of what I've encountered, it is reasonable to believe that. Okay, so the conclusion is, he's interested in me. Well, who wouldn't be? All right, now we want to know, once again, I can reuse my say diagrams, which is good because I'm lazy, because 3 is the conclusion. Work out what you think is the correct diagram. Who says A? Who says B? Who says C? Who says D? Now there are a couple for C. Let's look at if we can work that one out. If this is C, then 2 would be supported by 1. So in other words, I would say 2, and I'd say, what's your evidence? And 1 would be the answer. So 2 is, the other day he smiled at me. What's your evidence that the other day he smiled at you? 2, the answer is, he sat next to me in class today. Is that right? Now, him sitting next to you in class is no evidence at all for whether or not he smiled at you. So it's not this one. Who said B? A couple of timid people. Now it's not B, okay? But I can tell you why you might be tempted to think that. And that is, by themselves, the reasons he smiled at me, he sat next to me, on their own, they're pretty flimsy, aren't they? Because lots of people smile at you, particularly in friendly America, less so in England. But, you know, and lots of people sit next to you, because maybe that's the only seat there is. So by themselves, they seem pretty flimsy, whereas you think, well, but put enough of them together, you know, I turn on my light at night, and there he is outside the window, you know, it starts to add up, right? But in fact, what you've got to think is, don't think about how strong the argument is. Think about whether or not by itself it's remotely relevant. And it is remotely relevant. If he smiled at you, that is remotely relevant to him being interested in you. It's not strong, but we're not interested in strength. We're interested in relevance. Contrast with this. Lonnie is terrible at keeping track of details. Is not even remotely relevant to a career in the law by itself. Okay, whereas this one is relevant at least. All right? So, the correct answer is A. They're independent premises. It's a crappy argument. You're obviously a bit conceited if you believe that, right? Maybe, if, like I said, if it turns out he's a stalker, then we should have believed it. But that is the structure. Does that make sense? Let's look at number 3. Let's just keep doing them. Done.
Molly is a very bright child. She began speaking on her first birthday, whereas most children do not begin to speak until later.
Okay. What number represents the conclusion? 1. Does everyone agree? Yes. So the point of this argument is that Molly is a very bright child. What's the evidence? Well, what's supplied is the evidence. Are the premises given dependent or independent? I want a chorus, please.
Dependent.
I want a chorus, please. 1, 2, okay. There you go. Dependent. Why are they dependent? Well, you can. I mean, you could present them, but...
The point is improvement.
Yeah, so for example, if I just said, Molly is a very bright child, she began speaking on her first birthday. That doesn't prove it, because for all I know, they come out of the womb talking, right? You know? That's what movies have taught me. Look who's talking too. But it's when you add in the information that most children do not begin to speak until later. And which, of course, most children do not begin to speak until after 1 doesn't by itself prove anything about Molly, because it doesn't say anything about Molly. So that can't be an independent one. So basically, the correct diagram would be one like B, only with number 1 at the bottom. Let's skip ahead and give an example involving a sub-conclusion, because we haven't seen any like this yet. Well, look at page 99. Question number 5. It tells you the structure. You just have to fill in the numbers. It's kind of the reverse of what we're doing. So it says, since 1, my car won't start. 2, I will have to take the bus. So 3, I need to take exact change for the fare. First thing we need to know, Kyle, do you have your book? What is the conclusion? Who thinks they know? 3. So number 3 is, I will have to take exact change for the fare. Who agrees? Is that the overall point? Okay. So, good. I don't have to change my diagrams. We know that it is one of these. 3 is the conclusion. But either 2 is the direct support for 3 and 1 is support for 2, or the other way around. Which is the correct one? We have a vote for C. Anyone disagree? Well, let's try it out. Remember, if it works, then when you go up an arrow, incidentally, what does an arrow stand for? What's that? No, so what is the question that is answered when you hop across a plus sign. What does an arrow represent?
What's the other?
Not a question, what's that?
Therefore.
Yeah, or supports. An arrow stands for supports. Remember the definition of an argument? The premise supports the conclusion, so that's what's going on here. 1 supports 3 in this case. All right, now you said it was this one. Okay, well in that case, we say 3, which is, I need to take exact change for the fare. And then I ask the question, what's the evidence? And 2 should be the answer. I need to take exact change for the fare. What's your evidence? I will have to take the bus. Yeah. Or, what's your evidence or why, depending on which seems more appropriate. I need to take exact change for the bus. Why? Because I have to take the bus. Duh. All right, I have to take the bus. Why? This should be the answer. My car won't start. Does that work? Yes. So that's the correct structure of that one. All right. That'll do it for today. Do not forget to do your homework. Your homework. What's that?
I said, I'm really glad you're reminding us.
Well, you're not going to forget because you're all going to go away and do it right now. Do not leave it until the last minute being 10 p.m. on Tuesday.